All right, so now we want to take a look at independence of joint probability distributions, and we would like to begin with that of the independent joint PNF. Okay, so the discrete random variables x and y are independent if and only if the probability for their joint distribution, probability that x is equal to a particular value of x and y being equal to a particular value of y, can be expressed as the product of the imaginary probabilities as shown in equation 9 or equation 10. Okay, for all pairs of real numbers x and y. Okay, and we know the condition of this based on our previous knowledge on independence of two events. Okay, we know from our previous tutorial that when two events are independent, the probability that A or B will occur right at the same time can be expressed as the product of the individual probabilities. Okay, so that's basically what we have in equation 9 and equation 10. That is the same analogy we are trying to apply here. Okay, all right, so now let's take an example. Using the information from example 1, we want to find out if x and y are independent. Okay, so let's consider some ordered pair where x is equal to 0 and y equal to 1. So the joint PNF of this random variable where x is equal to 0, y being equal to 1 can be expressed in this form, and this is equal to 0.4. Okay, so we can check it out here. You can see that x being equal to 0 is here, and y being equal to 1 is here. Okay, so this is where it intersects the probability 0.4. Okay, so that's why we have 0.4. Now let's take a look at the imaginary probabilities. Probability that x is equal to 0 and y is equal to 1, which can be expressed in this form, is equal to that 0.36. Okay, so let's take a look at it. So x being equal to 0 is that's imaginary 0.56, and y being equal to 1 is here 0.6. Okay, so once we take the product is equal to 0.6, 0.36. So since the joint P and F of x being equal to 0 and y being equal to 1 is not equal to the product of the imaginary probabilities, it follows that x and y are not independent. Okay. All right. So now let's take a look at the independent joint PDF. So let x and y be random variables with joint PDF f of x, y, and marginal PDFs f of x and f of y respectively. X and y are independent if and only if the joint PDF, right, of x and y can be expressed as the product of the imaginary probabilities as shown in equation 11 for all pairs of real numbers x and y. Okay. All right. So let's take an example. Using the information from example 5, we want to determine whether x and y are independent. If you have skipped that for example 5, you can check out my previous tutorial on that by clicking on the link in the card above, or check the description of this video for the link. I think that will be on joint and marginal PDF. Okay, you can check that video out. So from example 5, we got to know that the marginal PDF of x is in this form, and that of the marginal PDF of y is in this form. Okay, so now I want to find out if x and y are independent, as the variables are independent. So we have to take the product of their marginal probabilities, and this is what we obtain. They can also be expressed in this form. Okay, now we can see that this is not equal to the joint PDF of x and y, so we can basically say that x and y are not independent. Okay, so this is a trial question. I'll leave the solution in the description of this video so you can check it out. Please, if you find value into this tutorial, don't forget to subscribe if you have not, and don't be scared to subscribe, because a subscription, anytime you subscribe, it is free of charge. There are no charges, so just try and subscribe if you have not, to support this channel. And thank you for watching.